Our group project was designed to see if there was a relationship between lower leg power and lower leg balance. To test for leg power, the subjects performed a vertical jump test and a modified long jump test. To test for balance, they were timed and asked to hold a yoga pose as long as they could. Our subjects included 22 active college students, 10 male and 12 female, that ranged from 19 to 22 years old. We had them each perform these 3 tests. Each group member was assigned to conduct one of the 3 tests and record the results. The first test we will discuss is the vertical jump test. As mentioned, the vertical jump test was used to assess leg power. The piece of equipment used to measure was the Vertec. The subjects were asked to stand with their arms fully extended above their heads to adjust the bottom of the levers to the top of their fingertips. They were then told to jump as high as they could while moving the highest lever they could reach. This was done twice, and the best value was recorded. The next test, the modified long jump, was also used to assess lower leg power.
In our modified long jump, we measured the first foot landed. You did not have to stick the landing on 2 feet. We gave each student 2 chances to try and improve their score. We used tape to mark the starting line and the jumping point. We used a tape measure to measure the distance that was leaped. We recorded both scores that were qualified and set an average goal at 9 feet. We checked scores and determined who was trained and untrained, and who was a master and who was not a master. Here is one of our group members, Kayla, recording the modified long jump scores.
For our third test, we had the participants perform the Eagle Yoga pose. This pose involves standing on one foot and crossing the other leg over it, while also holding both arms in front of the body entwined together. The purpose of this test was to determine balance and to later determine if it correlates with lower leg power. Our test was broken up into 3 categories. Holding the pose longer than 80 seconds was considered excellent. Holding it between 60 and 80 seconds was considered average, and holding it under 60 seconds was considered poor. This criterion was established by us, and we did not research the standards for a balance test of this sort. As you can see from the pie chart, most students were in the excellent category, with 82% of participants in the highest rank. Only 1 participant scored in the poor category, and 3 scored in the average category.
When comparing the vertical jump to the modified long jump, there is a strong positive correlation present, meaning as the height of one's vertical jump increases, the length of the long jump increases also. However, when comparing the vertical jump to the yoga pose, there seems to be almost no correlation, or according to the trend line, a very slight negative correlation. This means as the height of the vertical jump increases, the duration of the yoga pose decreased or stayed the same.
On this scatter plot graph, we measured the correlation of the modified long jump and the yoga pose. There was almost no correlation between the modified long jump and the yoga pose. Although according to our graph, it looks to be slightly negative. As the modified long jump increased, the yoga pose either stayed exactly the same or slightly decreased.
We used a variety of tests to compare our data in order to see if our results were statistically significant. After calculating the Pearson correlation, we concluded that there was a moderately high positive correlation between the modified long jump and the vertical jump. Our modified long jump test proved to be a valid test based on our validity coefficient of 0.73. There was no significant difference between the trained and untrained participants during the vertical jump test based on the t-test results.
Some of the sources of error occurred during the test as fault of the administrators. During the yoga pose test, the main source of error was due to unclear instructions of how to perform the yoga pose correctly. Some students created their own version of the eagle pose, allowing them to be more stabilized. This resulted in a majority of the class being highly proficient in the balancing portion of the yoga test. For the modified long jump, some of the sources of error happened because of the trained ability versus the untrained ability of some of the subjects. This showed how students were perceived as excellent long jumpers compared to pre-established criterion. Some of the issues that went along with the long jump included fears of students jumping. The grass outside was damp and instructions were to land on one foot. This caused some hesitation in the power of the long jump. Also, there was little to no room to get a running start behind the designated tape for the long jump. This affected how much power and momentum there was generated for the long jump. Vertical jump only had one source of error. Some of the students swung their arms on the way up on jumps when others did not use the aid of their arms to propel themselves upwards. Some students stood closer to the vertex and some stood farther away, which can also affect the jump height. In conclusion, the yoga pose was not proved to show a proficiency in balance. The greater the long jump lengths were correlated directly with the heights of the vertical jumps, which proves a significant relationship between both tests. The yoga pose duration for excellence category was achieved by most students, showing no relationship with vertical jump or long jumps. There is not a sufficient amount of evidence to prove that there is a significant relationship between lower leg power and lower leg balance based on the test performed and the results obtained.